Here's a little review for inequalities, and you can use examples that are similar to these in your activities that you complete this week. So make sure that you're creating your own, but you can use this video as a guide on the types of problems that you can include. So the first section, 1 to 4, this is where we have the graph of the inequality and we list what the inequality is. So this is one option for the type of problem that you could complete. So if I'm looking at number 1, a couple things that I want to notice is that I have an open circle at -2. So I always want to put the variable first, and then I put the number. And then it's just a matter of figuring out what inequality symbol goes in the middle. Open circles would either be less than or greater than. Closed circles would be less than or equal to or greater than or equal to. So since this is an open circle and the arrow is going to the right, it's going to be all the numbers greater than -2. For number 2, I can see that I have a closed circle at 6. So I write the variable first, then I write the number, and I see that all of the numbers less than 6 are shaded. The arrow's going to the left. So this is a less than or equal to symbol because it's a closed circle as well. The next type of problem that you could use is using multi-step inequalities. You can make them as simple or as complicated as you want. So example number 6 is a good one to start with. When you see these inequalities, the first thing we do is change the inequality to an equal sign, and then we solve this equation. So I have to divide both sides by -7 in order to get y by itself, and I get y is -3. So that means -3 goes in the middle of the number line. I look back to the original inequality and it has a less than symbol, so we have to use a closed circle. And in order to figure out which way to shade, we test 0. So I put 0 into the original problem in place of the variable. So this is -7 times 0. And I have to figure out if that's greater than or equal to 21. Well, -7 times 0 is 0. So ask yourself, is 0 greater than or equal to 21? Well, that is false. So when we have false, we shade far away from 0. If we get true, we shade toward 0. So since I got false, I have to shade far away from 0. Well, if -3 is already on my number line, this would be -2, -1, 0. So 0 is to the right, which means I have to shade far away from it. And then the last step is we look at our graph, just like we did with these first 4 problems. The variable comes first. The number is -3. And my arrow is pointing to the left, so this is all the numbers less than or equal to -3. I'll do one more like this for you. I'm going to look at number 7. So the very first thing to do is rewrite the problem with an equal sign instead of the inequality. So in order to undo this -8, we need to add 8 to both sides. So x equals 13. Now that means 13 goes right in the middle of the number line. I look back to the original problem and I have a greater than or equal to symbol, which means this is going to be a closed circle. And then in order to figure out where we're going to shade on our number line, we have to test 0 into the original problem. So this is x, I'm replacing x with 0. So this is 0 minus 8, and we have to figure out if it's greater than or equal to 5. 0 minus 8 is -8. So is it true or false? Is -8 greater than or equal to 5? That is false. So we have to shade far away from 0. Well, if we're already at 13 on the number line, 0 is going to be over here to the left. So I have to shade far away from that. Now, the very last step is to look at our graph. We always put the number first. We put the variable first and then the number next. And this is shading to the right, which is all the numbers bigger than or equal to 13. Now, this is the last type of problem that you could include in your activities this week. So these are real life situations that involve inequalities. So number 17, if you have less than $35 in your wallet, your inequality phrase is less than. And we're talking about having less than $35. So the variable goes first, 35 is our number, and then we have to have less than as our inequality. Number 18, you can eat up to 1,500 calories. So let's get this set up. We have the variable first. We have the number 1,500. Now, if I can eat up to 1,500 calories, can I eat more than 1,500 calories? Can I eat less than 1,500 calories? Can I eat exactly 1,500 calories? Hopefully you answered that you can eat less than or equal to 1,500 calories. Number 19, you can spend no more than $120. So variable first, number second. So ask yourself, can I spend less than 120? Can I spend more than 120? Can I spend exactly 120? So as you're thinking about the answers to those questions, hopefully you're thinking, well, I can spend 120 or less. So less than or equal to 120. And then we'll just do the last one. So the temperature will be at least 75. Let's get it set up. Variable first, number second, at least 75 degrees. Can it be less than 75 degrees? Can it be more than 75 degrees? Can it be exactly 75 degrees? If it's at least 75, it needs to be more than or equal to 75.